Welcome back, students. We have one more problem in section 4. Okay, here we go. A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. Can you visualize it? Well, the problem came with this picture, so maybe this will help. At what rate is the searchlight rotating when the man is 15 feet away from the point on the path closest to the searchlight? So, this problem is asking you the rate of change of this angle. This angle, the angle changes. How quickly is it changing? This problem is asking you the rate of change of the angle, and physicists call it the angular speed or angular velocity. Here, in terms of related rates, let's just call it theta prime or d theta dt. And as for relation, how can you get a relation here? Well, we have a right triangle here, but overall this picture gives you too much information. And that's the nature of 3D graphs, 3D pictures. Gives you too much information. So let's just focus upon the triangle here. So angle is theta, right triangle 20, and x is the distance the man is currently at from the nearest point from the searchlight, and x is changing because the man is man is walking away from this point, and the distance is increasing. So speed of 4 feet per second. And then what else? The searchlight is located on the ground 20 feet. That's already there. At what rate the searchlight rotating when the man is 15 feet away from the point? Oh, x value here is 15. Do you see that? Looks like that's the structure. So, this is a speed of the man, and then the distance he traveled so far, 15 feet away, and then the angle. Well, looks like that's the structure. So, can you find a relation between x and theta? Look at the triangle. Don't pay too much attention to this 3D structure, 3D picture. Look at the triangle, just plan a picture. What do you see? We have a right triangle. Right angle is here, theta is there, and x is the opposite, and 20 is the adjacent. See that? And hypotenuse, the problem does not talk about the hypotenuse. Distance from the searchlight to the man, that's not an issue here. X, opposite, 20, adjacent. So what's the relation? Opposite over adjacent. Agreed? Okay, all right. Let's take the derivative. Take the derivative implicitly. The derivative of tangent, we call that secant squared of theta. And then don't forget theta prime. How about the right hand side? take the derivative, 1/20th, and then don't forget x prime. Remember, whenever you take the derivative, prime pops up. This is related rates. Everything here is dependent. Independent variable or the parameter is t, the time. So this one here, theta prime, is the quantity I'm looking for, and the x prime is 4. And tangent of theta, that's going to be a bit of a problem. There's going to be a bit of a problem here. X is currently 15. It's hard to read. Let's write like this. X over 20 is correct, but let's rewrite it as 1 over 20x so that you can see this coloring a little bit better. This trigonometry is causing trouble. Tangent theta versus secant squared theta. Otherwise, we have 2 equations and 2 unknowns after plugging numbers. So it looks good. You see, x is what? Oh, I don't need to go all the way back. X is here, 15. So this is 15. On second thought, let's put in 15 up here again. And then let's put x back here again. Instead, let's increase the font for all. So 15 over 20, let's see, is it 3/4? Looks like it. 1/20th, x prime is 4. So x prime is 4, so that's 4. So what is 4 over 20? 1/5. So can you solve for theta? Excuse me, can you solve for theta prime? Well, from here, flipping the secant squared to the other side, I'm going to get 1/5. Well, that's what I'm going to get. But there's a problem. What is the secant squared? If I figure it out, then I'm going to get the answer. Any idea? We know tangent. Can you figure out secant squared? Well, I hope you guys remember this. What is secant squared? Secant squared is 1 plus tangent squared. And tangent squared, we know that tangent is 3/4. So this entire thing is 1/5. 1 plus, let's see, 3/4, so 9/16. And okay, I got a little bit tired of it. So let's put everything into a calculator. I'm getting 5 over 16, which is, as a matter of fact, excuse me, I don't need the approximation symbol here. Denominator is 16, so this is going to be a terminating decimal. If my computation is correct, that's what I'm going to get. let's go back to this picture. Man is walking, so x is increasing. X is increasing at the rate of 4, so x prime is 4. And from this picture, use trigonometry. Tangent of theta is opposite over adjacent, x over 20. So you're going to get that. Tangent of theta is x over 20. And then take the derivative. Tangent becomes secant squared, but chain rule theta prime pops up. X over 20, the derivative is just 1 over 20, x prime pops up. And let me change my mind yet once more. Yeah, like this. Okay. Now plug in numbers. X is 15 and x prime is 4. I want theta prime, so from here I can solve for theta prime. 4 over 20, 1/5. Oh, excuse me, I made a mistake. When I flip it over, the secant squared should have gone to the denominator. Flip it over, that should have gone to denominator. Oh. So that should have gone to the denominator. So this entire thing, I'm afraid, is going to be a little bit different. 16 over 125. (0.128). Yeah, that's the correct answer. Let's come back here. Sorry about an algebra mistake here. Secant squared theta prime is 120, so x prime here, alright. Plug the numbers in, x prime is 4, and then we want to solve for theta prime, so divide away secant squared. So that secant squared goes to denominator, 1 over 5 secant squared. Now use trig identity, secant squared is 1 plus tangent squared. And then what is tangent squared? Well, tangent is 3/4, 15 over 20. So taking the square, I get 9 over 16. So we have this computation to do. It's not too bad. And I just used calculator to do that, as you saw. 16 over 125, so 0.128. And then the unit will be radian per second. Yeah, we are doing everything with respect to seconds, so it's going to be second. And then as for the angle here, I didn't do any kind of adjustments to 360-degree thing, multiplying or dividing by pi over 180. So it has to be radian here. The unit is radian. Now, if you have to change it into degrees, then you have to multiply on 180 over pi here, but I don't think that's really necessary here. Let's see, what did I do in my answer key? Here is a 2D picture, tangent of theta, okay, alright, x is 20 tangent of theta, that's the same. Taking the derivative, we have secant squared. Plugging in the number, we have the relation on tangent, and then the one with secant squared. And, oh, here I use geometry. Instead of using trig identity, tangent is 3/4, so 3/4 triangle. Secant is 5/4. So plugging in and then doing the computation, 5/4 squared, and doing that, well, the same as before, 16 over 125 and 0.128. So 0.128 radians per second, or 7.334 degrees per second. Okay, all right. That completes this section.